right, continuing on with conditional probabilities, but changing our scenario away from a deck of cards. What is the probability when you roll 2 dice that you get a sum of 6, given that the first die is a 4? So again, if you want to look at the sample space for the first die being a 4, okay, so the sample space for first is a 4. Our rolls would look like 4-1, 4-2, 4-3, 4-4, 4-5, or 4-6. Those are the only possible outcomes if our first die is a 4. So knowing the first is a 4, we have 6 possible outcomes, and of those, there's only one where the sum is a 6. It is that one right there. And so the probability that the sum is 6, given that the first is a 4, is 1 out of 6, or about 0.167. Okay. For the next example, what is the probability of getting a sum of 9, given that the second die is a 2? So the sample space for the second is a 2, would be 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, or 6, 2. So 6 possible outcomes, and out of those, there is not a single one where the sum is a 9. 8 is the biggest sum we can get, and so 0 out of 6, or 0. That is an impossible event. Okay, we're going to define another term here. Okay, 2 events are said to be independent if one event happening does not change the probability of the other event happening. If they are not independent events, then the events are called dependent. Okay, so independent means the probability of one does not change the probability of the other. So, and that can be more than one event too, or more than 2 events, by the way. Okay, so let's take a look here. Independent or dependent. You roll 5 dice. So does the roll of 1 die have impact on the second roll? Does the second roll impact the third? Or are they all completely independent? Okay, again, these are events that are independent. One roll does not impact another. You are dealt 5 cards from a deck. This one is dependent because once you have been dealt 1 card, the sample space has changed from 52 cards in the deck down to 51, and so the probability of the next card being a whatever has changed, and so forth and so on, because the sample space size is changing. So those are dependent. Okay, you have 2 children in 2 separate births. The events are the first is a girl and the second is a girl. So again, if these are separate births, the gender of one child has no impact on the gender of the next one. These are independent. And if you flip a coin 100 times, does one flip have any bearing on any of the other 99 flips? Absolutely not. And so those events are independent. Okay. So we're going to start calculating the probability of independent events. And the way that you do that is you multiply the probabilities of each event happening in succession. And actually, this is true whether they are independent or dependent events, actually. This is not just about independent events. One of the things that I'm going to give you here as just a little helpful hint and a note that will make your life a little bit easier is if you have the word and, or you can say the problem with the word and in it, you can rephrase it, if you will. The word and often indicates multiplication. So that's one of the best ways that I try to rephrase the question to see if there's an and in there. If there is, then I will multiply. Okay, so let's take a look at a few examples here in number 4. You pick 3 cards from a deck. What is the probability they are all kings if the cards are replaced after they are picked? So once we get a card, we're going to put it back in the deck, reshuffle, and pick another one. Okay, so for the first card, there are 4 kings out of 52 in the deck. Okay, so what we're looking for is the probability of a king and a king and a king. So and means multiply. I put that card back, I reshuffle. There are still 4 kings out of 52 cards in the deck. And I put that card back and I pick again. There's still a probability of 4 out of 52 that card is a king. Okay, and so that ends up being about 0.0005 on your calculator. Sometimes that will show up in scientific notation, and so do be aware on your calculator. It may say something, and it depends on your settings, but you might get something like an E. So for example, 5e negative 4, that means 5 times 10 to the negative 4th power. And that means you need to move that decimal in front of the 5, 1, 2, 3, 4 spaces over to give you your new value. So just be aware that that may pop up on your calculator. It's worth taking a peek at. All right, a few more here in example 4. Suppose you pick 3 cards from a deck. What's the probability they're all kings if the cards are not replaced after they are picked? Okay, so the probability your first card is a king is 4 out of 52. And we need another king, but we did not put that card back. So there is a king missing from the deck. So now instead of 4 kings, there are 3. And instead of 52 cards in your pile of remaining cards, there are only 51. Okay, and we need a third king. So now in the deck, you're holding 2 kings. There are 2 remaining, and there are 50 cards left in that deck that have not yet been dealt out. Okay, and again, double check. You might run into that scientific notation, but the probability is about 0.0002. Pretty slim chance that that's going to happen. Okay, you roll 5 dice. What is the probability you roll 5 even numbers? So we need an even and an even and an even and an even and an even. So we're going to do a lot of multiplication. On the dice, 3 out of 6 are even. So I'm going to write 3 out of 6 instead as 1/2. Okay, so the first one is 1/2, and the second 1/2, and the third, and the fourth, and the fifth. And that ends up being about 0.031 as the probability. And finally, you roll 5 dice. What's the probability you roll the same number on all 5 dice? Okay, so rather than thinking of rolling these all at the same time, it might be helpful to think of rolling these one at a time. So the first roll, whatever you get, that's determining the number that is now the same number. So that first die, you can actually get anything you want. And once you see that number, let's say it's a 4, now you are forced to roll 4s for the remaining 4 dice. So the probability you would get a 4, for example, or any of the other numbers is 1 out of 6 for the second die, 1 out of 6, 1 out of 6, and 1 out of 6. So this can be any number, and then you have to match the first all the way down. And the probability you match the first number is 1 out of 6 in each case. That ends up being about 0.0008.